We're going to work on case 2 of Thevenin equivalent, but before doing that, let's review the first case of the Thevenin equivalent circuit. The first case includes only independent sources, voltage sources or current sources, and resistors. The steps are the following. We first need to find the Thevenin voltage. And once we find the Thevenin voltage, we proceed to find the Thevenin resistance. Thevenin voltage and Thevenin resistance will give us the equivalent circuit. For case number 2, we include dependent sources. So we have independent sources, voltage sources, or current sources plus resistor, and dependent sources. In order to find the Thevenin equivalent circuit, we first find the Thevenin voltage or the open circuit voltage. Then, since we have a dependent sources that cannot be turned off, it will remain for all the analysis. We then look for the short circuit current. Finding the Thevenin voltage and finding the short circuit current would allow us to find the Thevenin resistance. The Thevenin resistance is the ratio of voltage of open circuit divided by short circuit current. With the voltage of open circuit, or the Thevenin voltage, and the Thevenin resistance, we build our equivalent circuit. So let's start with the following problem. We have this circuit that has one dependent source, and we want to find the Thevenin equivalent circuit. First, we need to identify the load resistor, and then we need to label the terminals across the resistor. Once we do that, we can remove the load resistor so that we can find the Thevenin voltage, the short circuit current, and the Thevenin resistance. So let's start by finding the voltage of open circuit, or the Thevenin voltage. Level the top terminal positive, lower terminal negative. We notice that through the 3 ohm resistor no current flows, or current is 0. The only current is the dependent current, equal to V sub x over 4, that flows through the circuit. We notice that the voltage of open circuit is equal to V sub x. We could write Kirchhoff's voltage law, but we don't know the voltage across the dependent source. So we write a Kirchhoff's voltage law. Voltage of open circuit is equal to 2 ohms times the dependent current plus 4 volts. Since the voltage of open circuit is equal to V sub x, then we write that V sub x equal to V sub x divided by 2 plus 4. We solve for that, and we find that V sub x, that is equal to the voltage of open circuit, is equal to 8 volt. So the Thevenin voltage is 8 volt. Now let's find the short circuit current. In order to do that, we place a short circuit across the terminals x and y. We know that the dependent current source is V sub x divided by 4. We notice that when we place the short circuit across the terminals, that short circuit makes V sub x go to 0. If V sub x goes to 0, this makes the dependent current source V sub x divided by 4 go to 0. And a current source going to 0 is an open circuit. So we'll remove that from the circuit. Now the only current that flows through the circuit is the short circuit current. So we can write an equation. Short circuit current is equal to 4 volts divided by 2 plus 3 ohms, and that's equal to 4/5 of an amp. And that's the short circuit current value. Now that we have the value of the voltage of open circuit and the value of the short circuit current, we can find the Thevenin resistance by writing our equation that Thevenin resistance is equal to voltage of open circuit divided by short circuit current, and that's equal to 40 divided by 4 equal 10 ohms. So our Thevenin equivalent, a circuit has a Thevenin voltage equal to 8 volts and a Thevenin resistance equal to 10 ohms.